Hey everybody, Thrasher here. In this video, we are looking at what a force is, as well as this idea of weight and mass. Three words that you may have heard before, but we're going to look at the physics definitions. And of course, if you haven't heard about one of these words or multiple, that's okay too. But we're introducing these terms that are important in our physics class, okay? Some definitions, that's largely what this video is. First, a force. The best definition is this one right here, okay? Anytime you are pushing or pulling on an object, you are exerting a force. And all four of these diagrams are examples of forces. Whether you're playing a contact sport like football or soccer or tennis, all of those are involving forces. Whether you do dance or ballet, any kind of musical instrument has you applying a force, you pushing or maybe pulling on something. Anytime you're using your muscles are contracting, they are pulling on your tendons and bones. Anything and any time you have a push or a pull, that's an example of force. And that even extrapolates to like planet Earth. Planet Earth exerts a force on us. It pulls us downward. So that's it. That's what a force is. Any kind of push or pull. All right. How we measure forces, especially in like a physics classroom, there's a couple of different ones that I have right here. This right here is known as a force scale or a spring scale. Very similar to the word bathroom scale, like we use to find your weight. This uses a spring and you can attach it with this hook and you can pull on it and you can see how much force is being required to maybe pull an object across a table, or you could hold it vertically and see how much force is needed to keep it suspended. This thing right here is very similar. It also measures force. This is just a digital example. This one that I have in my own classroom is connected, or at least it can be connected to our computers. The nice thing for this one is not only can you pull on objects and measure force, but you could also push on it. And so you could do both types based on this definition right here. But that's force, really a pretty simple definition at the most basic level. The next word that we're going to define for us is mass. Mass is how much stuff makes up an object. I really like this picture, this example using Legos. We know that with Legos, this toy, we can construct all kinds of things. Now, the size of your Lego set is based on how many pieces you have. If you have more of these small Lego pieces, you have a bigger set in general. Likewise, if you have more pieces that make up you or the table or your television, the object has more mass, generally speaking. So if there's more things, like for me, it might be more organs, more cells, more atoms. The more of those you have, you usually would say you have more mass, okay? It's also like when you're balancing two things. If you're trying to find out like what two things balance and you use one of these classic looking scales, what you're doing is you're comparing the mass. You put on enough little objects on both sides until they equal. That is showing you have the same amount of stuff making up those two objects. The way we measure mass in physics class is with something known as a kilogram, okay? This is a kilogram right here. Kilo means 1,000. So a kilogram actually represents 1,000 grams, the second part of this word here. Well, what's a gram? A gram is about a paper clip. So if you have a paper clip resting in your hand, you are showing about 1 gram worth of stuff. Mass has some other definitions, like if you're personally in my own class, you might see another definition for mass about something having to do with this word known as inertia, but I won't get into that now. But also mass has very much a lot to do with standard or modern physics. Mass is related to something in quantum mechanics known as the Higgs field. We're not going to get into that either. So I know this is kind of maybe a silly looking definition, but it's one that's fine enough for us in this class, okay? Okay, so we talked about force, we talked about mass. I actually kind of want to go back to force because let's look at one example, one type of force, and it's known as weight. And this is a type of force that you're all very familiar with. It comes from the fact that Earth pulls us downward. We call this force that pulls us down, or if you got a tennis ball in front of you, pick it up, let it go, you will see the tennis ball falls down because Earth pulls it downwards. This is called weight, or the force due to gravity. These two phrases are interchangeable. They both mean the same thing. How do we measure force? I know I defined it on a prior slide, but we didn't talk about how we measured it. You know one way to measure force, even if you didn't kind of make the connection. Pounds. When you stand on a bathroom scale, you are measuring how much the Earth is pulling you down. You're measuring this force due to gravity, and it's giving you a number in pounds. That's one way to measure force. You could say shove a table, and you could measure how many pounds of force that is, okay? But I'm sorry to say, just like how we're not using hours for time and we're not using inches for distance, we are not using pounds in my own physics class, at least in most physics classes in general. We're not going to use pounds to measure force. We're going to use something known as a newton. A newton is a smaller amount of force. It takes about 5 newtons to equal a pound. Or here's a good way to think about it. A newton of force, or a newton of weight, is really about the weight of one medium-sized apple. If you're holding an apple in your hand, that weight that you feel in your hand is about 1 newton, okay? Well, we've learned to use equations for some of our physics terms. Weight has an equation, and this is why we talked about mass before I jumped to this slide. The equation for weight's a little weird, but you're going to see it's not very challenging, at least in my own opinion. Weight, how many newtons of force, is based on the object's mass multiplied by this thing that's written as g. All right. Now, again, scientists are often lazy. Instead of writing this whole thing out in words, we can use symbols. The mathematical symbol for weight is often W. The mathematical symbol for mass is M. And here's just that G again. I almost just copied it down. So we know what M is. That's the mass, and that's, again, something measured in kilograms. G is a little weird, but not difficult weird. G is just a number. G is, in fact, the number 9.8. That's all it is. This is not going to be changing based on the scenario. It's not changing based on the location. Whenever you use this equation to calculate the weight of something, whenever you see this G, you're just going to, in your calculator, in this case multiply, you're just going to type in 9.8. This 9.8 is actually a pretty common number in physics, so scientists give it its own special letter. But that's it. So really, to find the weight, it's not too tough. You just take the object's mass. Let's say I wanted to find my own weight in newtons. If I had a mass of 60 kilograms, I would, in my calculator, do 60 multiplied by 9.8. And that's it. That's how you would figure out the weight. Okay? This is my last slide, all right? Team, the final thing I want to talk about is a confusing thing that students often have, especially since in like an outside of science class context, these two words are often used interchangeably. And while it's not a big deal, we need to recognize that weight is not the same thing as mass. Mass, if you remember from the prior slide, if not, it's written down right here, it has to do with how much stuff is making up an object. It's this thing measured in kilograms, or sometimes grams, that we can convert, okay? That's what mass is. I have a certain number of cells and atoms in my body, whether I am here, or in New York City, or in Paris, or on the moon. Those cells are staying with me. This mass of mine is not changing. But weight is a force having to do with the Earth pulling us down. You could go to another planet theoretically, but these different planets are pulling down on us with different amounts of force. I like this picture, even though whoever made it clearly meant to write down Earth, Mars, and the moon, but they accidentally wrote down mass. But they're showing how if I look at the Earth and Mars and the moon, an object's mass stays the same because how many atoms make me up doesn't change. But how strong the planet or the object beneath my feet is pulling me down, that does change. Big deal? Not really, but we sometimes got to be careful. If there's a lab and it says you need to know the weight of an object, if you were to write down the mass of the object thinking those two things were the same, you would almost certainly get the wrong answer at the end of whatever the experiment or calculation is. So weight is not the same thing as mass. Weight is an example. It's a type of force. Mass is how much stuff makes you up. Okay, that's all I got for this video. Thanks a lot for watching.